Hello students, welcome to my class. Students, from our earlier classes we know about resistance of a conducting wire. Students, sometimes in electronic circuits single resistance will not serve the purpose. So in that case combination of resistance, or you can say combination of resistors are required. Clear? To get the desired value of resistance in a circuit. So today we shall see basically how resistance can be combined. Clear? So for that concept of Ohm's law need to be clear. Clear? You cannot simply say, if I ask you what is Ohm's law, you cannot simply say it's V equals to IR. No. If you simply remember the formula without knowing the concept, then it will be difficult for you to understand the concept of combination of resistors. Yeah. So first of all, we shall review the Ohm's law, then only we shall start about combining resistors or resistances. Clear, students? So briefly I will see what is Ohm's law. So students, we know that, for example, this is a conductor, clear, and V is the potential difference. V is the potential difference between these 2 points. Say these 2 points are A and B. So what is V? V is the potential difference between A and B. Clear? And because of this potential difference, current will start flowing. So let I be the current. Clear, students? Then according to Ohm's law, current flowing through a conductor, please concentrate, the magnitude of current flowing through a conductor is directly proportional to the potential difference across the ends. Clear? If I is the magnitude of current flowing between A and B and V is the potential difference between A and B, then I is directly proportional to V. Clear, students? What is V? You cannot simply say potential difference. It's potential difference between A and B. Clear, students? What is I? I is the current flowing between A and B, like that. Clear? After that, you know it is equals to 1 by RV and V equals to IR. Now what is R again? You cannot simply say R is resistance. Clear? What is R? R is the resistance between A and B. R is the resistance of the wire between A and B. Obviously resistance is a property of conductor. So from A to B the resistance is R, like that. Clear? Clear? Now we shall start about combining resistances. How resistance can be combined. So there are basically two types, or you can say two ways in which resistors can be combined. One is series combination, another is parallel combination. Clear, students? So let's get started. So first of all we shall see what is series combination. Series combination of resistors. Clear? So students, if resistors are connected end to end like this is one resistor, let its resistance be R1. Then another resistor has to be connected one after another, or you can say end to end, like this. Clear? Clearly you can see that to the end of R1 another resistance of R2 is connected. Again to the end of R2 another resistor of R3 is connected. So these resistors are connected end to end. These resistors are connected end to end, and this type of connection, this type of combination is called series combination of resistors. Clear, students? So in another way you can see that here there is only a one way, in which current can flow. Clear? That means same current will flow through R1, through R2, through R3. Clear, students? Just consider this as a pipe. And current as water. So clearly you can see that same water will pass through R1, R2 and R3 like that. So this must be clear that in a series connection, resistors are connected end to end and same current flows through each of the resistors. Clear, students? Clear? So this type of connection is called series combination of resistors. Now we wish to find the equivalent resistance of this combination. That means, what do you mean by equivalent resistance? So clearly you can see that R1, R2 and R3 is connected in series. Clear? Now how to find the equivalent resistance, or what is equivalent resistance? Equivalent resistance means that value of resistance which will be equal to the combined value of these three resistances. Clear? For example, okay, I will come to the example later on. Let us first of all start this. So these are R1, R2 and R3. Now let us connect a cell across this combination. Clear, students? Now let this point be A and this point be B. Clear? Let this point be C and this point be D. Clear, students? Now clearly you can see that end points of resistors are different. If I ask you what is the end point of R1, you would say A and C. What are the end points of R2? You would say C and D. What are the end points of R3? You would say D and B. So clearly you can see that the end points are different. That means the potential difference across the resistors will be different. Clear? So what is V1? What is V1? It is the potential difference between A and C, or you can say it is the potential difference across this resistor of resistance R1. Similarly, say V2 is the potential difference across R2. Clear, friends? And V3 is the potential difference across R3. Clear? Clear? And suppose this cell has a potential difference of V. So if I ask you what are the endpoints of the cell, of this cell, clearly you can see it is A, another is B. Again, what are the endpoints of this cell? You would say A and B. That means if I ask you what is the potential difference between A and B, so clearly you can see it's V. What is V? V is the potential difference between this and this. And what is the name of this point? It is A basically. And what is the name of this point? It is B basically. So what is V? V is the potential difference between A and B. Or you can say V is the potential difference across the combination. Clear, students? Clear? Now, let's concentrate. For example, with the help of a voltmeter. Now, what is voltmeter? We know that voltmeter is a device which can measure potential difference between 2 points. Now, with the help of a voltmeter, say we have measured potential difference between A and B. So it is V. Clear? Again, we have measured potential difference across A and C. Say it is V1. We have measured potential difference across C and D. It is V2. we have measured potential difference across D and B. V3. With the help of voltmeter, we have measured potential difference across A and B, which is V, then across A and C, which is V1, then across C and D, which is V2, then across D and V, which is V3. Now, after that, we will see that V will be equals to V1 plus V2 plus V3. If we actually perform this activity, then obviously we will see that potential difference across the combination, let's concentrate, when resistance are connected in series, when resistances are connected in series, potential difference across the combination is equal to sum of the potential difference across the individual resistances. Clear? Clear? Now please concentrate. Now students, let us consider that I current is flowing in the circuit. Clear? So obviously I will flow like this, and again it will come back in this direction. So if I ask you what is the current flowing through the combination, it is I. What is the current? What is the value of current flowing through the combination? It is I. If I ask you what is the value of current flowing through R1 or R2 and R3, you would again reply it is I only. Clear students? Clear? Now please concentrate. Now we are going to apply Ohm's law. What is V? It is the potential difference between A and B. Clear? So it is equals to I. What is the current flowing between A and B? It's I. And what is the equivalent? What is the combined value of resistance between A and B? That we don't know. Let us write it as Rs. Clear students? We are basically applying Ohm's law. Potential difference across these 2 points is V is equal to current flowing between A and B, which is I. And what is the equivalent resistance between A and B? What is the combined resistance between A and B? We don't know. We have taken it as Rs. Clear? S for series. Simple. So what is this? This is the combined resistance. This is the combined resistance. Clear? Total resistance kind of. So what is V1? V1 is the potential difference between A and C. So what is the current flowing between A and C? It's I. And what is the resistance between A and C? It's R1. Clear students? Clear? Then what is V2? That is potential difference between C and D. Then what is the current flowing between C and D? It's I only. And what is the resistance between C and D? It is R2. Similarly, what is V3? It is the potential difference between D and B. So what is the current flowing between D and B? It's I. Clear? And what is the resistance between D and B? It's R3. Clear students? Clear? So please keep concentrating. So here we will take I outside. Clear? So I got cancelled out. So clearly you can see that equivalent resistance is equals to sum of individual resistances. So this thing you need to remember. If resistances are connected in series, let's concentrate. If resistance are connected in series, then equivalent resistance or combined resistance will be equal to the sum of individual resistances. Clear friends? Suppose, for example, suppose it is 2 ohm, it is 3 ohm, it is 4 ohm, it is 1 ohm, and clearly you can see that they are connected in series. They are connected one after another, end-to-end connection. Clear? And if current flows, same current will flow through each of the resistances. So they are connected in series. Now if I ask you what is the equivalent resistance or what is the combined resistance, then simply we will add this 2 plus 3 plus 4 plus 1. It's 5, 5 plus 5, it's 10 ohm. Clear, students? Clear? Clear? So it is not that only two resistances or three resistances can be combined in series. You can combine n number of resistances. Clear? Students, now we shall see how resistors are connected in parallel. So, in parallel combination, resistances are connected repeatedly between two common points. Clear? So, everything will be clear, nothing to worry about. So, this is a resistor of resistance R1. Clear? And it is connected between, say, A and B. So what are the endpoints of this resistor? It is A and B. Now if you connect another resistance, say R2, between A and B only, like this, then they are said to be connected in parallel. They are said to be connected in parallel. Clear, students? Let us take one more. Clear, students? So what are the endpoints of R1, R2 and R3? So clearly you can see that their endpoints are common, that is A and B. So if resistances are connected in this way, then they are said to be connected in parallel. They are said to be connected in parallel. Now let us connect a cell between the combination or across the combination. Clear? So say V is the potential difference maintained by this cell between A and B. Obviously, if I ask you what are the endpoints of this cell, what are the endpoints of this cell, then you would say it is connected to A and to B. So A and B are the endpoints of this cell. And what is V? V is the potential difference between A and B. Clear, students? Clear? If I ask what is the potential difference, what is the potential difference across R1? V only. What is the potential difference across R1? It's V only. Clear? Because R1, R2 and R3, they have same endpoints A and B. Even the battery has, in this case, even the battery has same endpoints A and B. Clear? So what is V? V is the potential difference between A and B. What is the potential difference across R1? It is again V. What is the potential difference across R2? V. What is the potential difference across R3? V. Clear, friends? So this thing is again very important that you need to remember, that when resistors are connected in parallel, when resistors are combined in parallel, then potential difference across each resistor should be equal. Clear? Clear? Now students, let us suppose that I current is flowing in the combination, is flowing through the combination. So obviously again I will come. Now what is I? It's current. And what is current? It's basically flow of charges. It is basically flow of charges. So now if you simply apply your logic, clearly you can see that if I is coming like this, same I cannot go through R1, R2 and R3. Clear, friends? Clear? If I is coming like this, what is I? It's basically flow of charges. So same I, same current cannot go through, I cannot go through R1, I cannot go through R2 and I cannot go through R3. So obviously what happens here, after reaching this point A, I will get divided into say I1 through R1, I2 through R2 and I3 through R3. Clear, friends? Clear? So from the battery I current is coming out, and here because of three different paths I has got divided into I1, I2 and I3. Clear? So just simply if we apply your logic, clearly you can see that I is equals to I1 plus I2 plus I3. I is equals to I1 plus I2 plus I3, because I is the total current which basically got divided into I1, I2 and I3. Now if you want to check this thing, if you want to be sure about this relation, then what you can do, you can connect one ammeter here, you can measure I1. All of you know that ammeter is a device with the help of which we measure the current flowing through that device. So if we connect one ammeter here, we can with the help of that ammeter we can measure I1. If we connect one ammeter here, with the help of that ammeter we can measure I2. Similarly we can measure I3. Similarly we can measure I. After that, very easily we can see that I is equals to I1 plus I2 plus I3. Clear, students? Now if I ask you what is I, you can say I is the current flowing through the combination. Through R1 it is I1, through R2 it is I2, through R3 it is I3. But what is the current flowing through this combination? It is I. Clear, students? Clear? Now please concentrate here. We know this relation V equals to IR, then obviously I will be equals to V by R, right? Now please concentrate. What is I? Last time, what is I? It is the current flowing through the combination. Now if I ask you what is the potential difference across this combination, you would say V. Clear? Now if I ask you what is the equivalent resistance, what is the combined resistance between this point and this point, then you would say, I don't know, let it be RP, P for parallel. Clear, students? Clear? Similarly, what is I1? It is the current flowing through R1. So what is the potential difference across R1? I have already explained, it is V. It's V again. Same endpoints, R1, R2, R3, they have same endpoints, so same potential difference. Clear? So what is I1? It is the current flowing through R1. So what is the potential difference across R1? It's V. Clear? And what is the resistance? It's R1. Similarly for this, you can write V by R2. And for this, you can write V by R3. Clear, students? Now you can take V common. So V got cancelled out. So you got the relation so this is the relation that you need to remember. What is RP? You cannot simply say or simply read this as RP. This is equivalent resistance, or you can say combined resistance of the parallel combination. Clear? This is the equivalent resistance of this combination. If I replace this R1, R2 and R3, if I wish to replace this R1, R2 and R3, this combination with a single resistor, then the value of that, the resistance of that resistor is given by this formula. Clear? Clear? So clearly you can see that if R1, R2 and R3, if resistances are connected in parallel, then reciprocal, please concentrate, reciprocal of combined resistance is equal to sum of reciprocal of individual resistances. For example, say we have 2 ohm, 4 ohm and again say 6 ohm. These are the 3 resistors connected in parallel. And if I ask you what is the combined resistance of this combination, you would say it is equals to 1 by 4 plus 1 by 2 plus 1 by 6. After that, you know obviously how to take LCM and all, and you will get the result. Clear, students? Clear? So I hope everything is clear. and if you find any part difficult, I would ask you to go through that part repeatedly. And very important that the concept of earlier classes should be very much clear, then only these things will be very easy for you. Clear? So see you in the next class. Thank you.